Okay. I guess, yeah, now my audio should be clearly audible. Yeah, so we are live. Let's wait for some time and then we will be beginning. I'm not expecting much people to be here, but yeah. So before that, before starting, let me tell you that how we will be moving on. Okay, so we can have this here, which is let's have a board, which is diagram. I guess diagram IO. I guess, yeah. So it was diagram IO. Yeah, no, this one. Got it. Yeah. So let's talk about it. That how we will be moving. So so first, this one is our starting. Okay. First, we have to find the problem statement and data set. Problem statement, I already said it is house price prediction problem. So first, we will find data set. Okay. So we will be finding a data set. Then we will be finding. Okay. So then we will be importing all or setting our environment. So our environment will be basically VS Code. So I will write it env only so that you can understand, or the best thing will be IPONV. So we will be setting our notebook. Okay, so this is our notebook which we will be setting, and then in notebook we will be going through multiple steps. So I'm not mentioning that steps for now, okay, because I will be explaining them in deep later. So after setting it, then we will be doing what? We will be analyzing it, checking it, and importing it in models. So there will be a models folder. We will be importing it in a pickle file. So I will write model.pickle. We will be importing it there, and so we will be importing them there, and it will be like this. And that models.pickle will be used for a backend. So let me make it clear that this is the flow. This is how the flow will be. Okay, so that model.pickle will be used in the backend. So backend call we can do in other lives, but for now we will be solely focusing on how the models will be trained, how we will be doing data processing, data cleaning, pre-processing, right, and then visualizing it, how the things are, and then after visualizing we will be saving model, also how to make requirements file, how a complete reproducibility of some models are made, and also not a single model, we will be using different models to train the same data set to solve the same problem. So this is how it is. Okay, then we are talking about notebook. Okay, so in notebook, let me be clear about it if you found it interesting. That in notebook here, so in notebook we will be starting from capturing data or acquiring the data. Is a very fairly simple process because we are going to use Kaggle data set, right? But in reality, when we talk about real scenarios, right, it is really tough. So we will be talking about data collection. Okay, this is different from other things, so we will be leaving it here. We will be having other things. Then after data collection, it will be data cleaning. Okay, so when we collect data, it's not always the case that our data is clean and we are getting everything. There are some rules, okay, which are not well maintained. Okay, so just suppose we are having a data of a person where his name is not there, his age is not there, only his phone number is there with an ID number. So this data is kind of useless for us, right? Similarly, that like out of 10, if 7 rows are missing, 7 columns are missing of a row, so that data is useless for us. तो ऐसे डाटा का हमारा उतना काम नहीं हो पाता, तो ऐसे डाटा को हम जनरली हटा देते हैं. और वो कैसे करते हैं, आई विल शो यू दैट. देन वी आर टॉकिंग अबाउट डाटा क्लीनिंग, एंड इसके बाद आ जाता है फीचर इंजीनियरिंग, जो आपकी आ जाती है थोड़ी सी. इसमें आप विजुअलाइजेशन बोल सकते हो कि आप विजुअलाइजेशन बोल सकते हो, सॉरी फॉर द स्पेलिंग, बट आप विजुअलाइजेशन बोल सकते हो. ओके, देन वी आर टॉकिंग अबाउट विजुअलाइजेशन के बाद हम ईडीए करते हैं, ठीक है, जो कि EDA होता है, एक्सप्लोरेटरी डाटा एनालिसिस. वी डू इट, एंड देन आफ्टर दैट वी डू व्हाट, पहले तो इनको लिंक कर देते हैं थोड़ा सा, क्योंकि विजुअलाइजेशन वाला और EDA वाला पार्ट जो है उसको मैं डाटा क्लीनिंग के ही एज अ सबसेट देखना चाहूँगा, क्योंकि सॉरी, तो ऐसा आई डोंट नो ऐसा क्यों है, इसको ऐसा कर लेते हैं और एक और ये करते हैं जो कि होगा इस पे, है ना. तो वी विल डू इट लाइक दिस, एंड देन विजुअलाइजेशन करने के बाद जो भी हमको निकला दैट विल नॉट बी दैट यूजफुल, बट या EDA करने के बाद जो भी हमें निकला उसको हम फीचर ENG करके, फीचर इंजीनियरिंग करके बेटर बना सकते हैं, ठीक है. और फीचर इंजीनियरिंग इज रियली यूजफुल बिकॉज आई विल टेल यू व्हाई. ओके, इसको कट करते हैं और ये नोड को डायरेक्ट कर सकते हैं. तो देखो, फीचर इंजीनियरिंग बहुत ज़्यादा यूजफुल हो जाता है. मैं एक एग्जांपल देता हूँ जिससे आपको डेट ऑफ बर्थ मिली हुई है, ठीक है. डेट ऑफ बर्थ को एक मॉडल में यूज करना इज नॉट दैट यूजफुल, बट इंस्टेड ऑफ दैट इफ यू आर यूजिंग देयर एज, ओके, बेसिक से लेते हैं थोड़ा सा. सो इफ यू आर हैविंग हेल्थ डाटा, ओके, एंड हेल्थ डाटा में जनरली क्या होता है that people prefer like the earlier which used to be was date of birth. Okay, so date of birth लिखवाते हैं, and then so हमारा जितना भी डाटा है उसमें डेट ऑफ बर्थ है, बट डेट ऑफ बर्थ से मॉडल ट्रेन करने में सेंस बनती है, नहीं बनती. क्या होता है अगर हम एक हेल्थ मॉडल बना रहे हैं जिसमें हमको हार्ट रेट प्रेडिक्ट करना है, ठीक है, तो 2 साल के बच्चे को हार्ट रेट आने के चांसेस कितने हैं, वेरी मिनिमम. बट एक 80 साल के बुढ़े, 70 साल के बुढ़े, सॉरी फॉर द वर्ड्स, बट एक 70, 70, 85 इस साल के किसी इंसान को हार्ट अटैक आने का चांस बहुत ज़्यादा होता है, राइट. तो दिस इज यूजफुल फॉर अस. तो ये जो डाटा है, दिस पर्टिकुलर एज इज रियली यूजफुल फॉर आवर मॉडल, बट डेट ऑफ बर्थ इज नॉट यूजफुल. तो हम फीचर इंजीनियरिंग करके उन फीचर्स को एक्सट्रैक्ट करते हैं जो हमारा एग्जिस्टिंग डाटा होता है उससे. समटाइम्स देयर आर थिंग्स वी डोंट इवन यूज, ओके, विच आर लाइक, अगर आपकी लोकेशन आ जाती है इसमें, ठीक है, तो इसमें आपका घर कहाँ है, आपका हार्ट अटैक से बहुत रेयर कनेक्शन होता है. अभी तो देयर कैन बी थिंग्स, ओके, इन कॉम्प्लेक्स मॉडल या लोकेशन कैन मैटर, बट जनरली ऐसा होता है कि मैटर नहीं करता है, ठीक है. अगर आप दिल्ली से हो या बेंगलोर से हो, डजंट मैटर दैट आपको हार्ट रेट आने के चांसेस ज़्यादा होंगे या कम होंगे, दैट मच. ओके, सो दिस इज हाउ इट वर्क्स. In complex cases it does work, like does get related, but yeah, for basic cases it does not. Okay, so these are all the things, and then we will be dealing with all the things. So this is a basic flow. I will be telling you more. Okay, so here there is one more thing which we can include, that is training, right? Training, training is there. Okay, then there is evaluation. Okay, so we will write eval for the evaluation thing. Okay, so ये होता है कि हम लोग को evaluation करना होता है, राइट? हम लोग को सारी चीज़ें देखनी होती है, ट्रेनिंग करना होता है, evaluate करना बहुत ज़रूरी है, क्योंकि ट्रेन किया पता तो चलेगा कितना बेटर है, राइट? अगर हमने एग्ज़ाम दिया तो मार्क्स से ही पता चलेगा, राइट, कि कितना अच्छा आया है या कितना अच्छा हमारा पेपर गया था, कितना अच्छा हम पढ़ के गए थे। तो वैसा ही है, इवेल्युएशन इज ऑल्सो रियली इंपॉर्टेंट। एंड इसके बाद जो चीज़ें हैं जो मैंने बताया, मॉडल डॉट पिकल फाइल बनाना, बैक एंड रन करना, सो दिस थिंग्स आर एंड टू एंड थिंग्स। ओके, आप सिर्फ मॉडल बना के क्या क्या कर सकते हो? कुछ नहीं कर सकते। यू जस्ट सी दैट अच्छा ठीक है मेरा मॉडल अच्छा वर्क कर रहा है, बट व्हेन यू आर वर्किंग इन सम company for as an intern, as an ML engineer, AI engineer, right? So this model should be useful. Okay, that's the thing, this model should be useful. So हम लोग इसको साइड रखते हैं एंड डायरेक्ट अपने इस पे चलते हैं। तो इससे पहले मैं आपको दिखा देता हूँ कि हम लोग कौन सा डाटा सेट यूज़ करेंगे। सो लेट्स गो टू Kaggle. ओके, let's go to Kaggle, and we are going to use the data set which is house prediction data set, and here the data set is there. So here the data set is, so this is our data set. Okay, here you can see that the price is there, bedroom, bathroom is there. Okay, there are 18 columns, price, bedroom. No, not this data set, I guess, because having a good data set is important. So we will be using some data set which is, well, yeah, I guess lot front street is there. There are total 81 columns, I see. This is also big data set, I see. So let's not use this data set. Also we need a like basic data set which will be useful for us. Okay, a data set which is minimal and useful. So this is submission.csv, 2 columns. Yeah, this is also not good. Let's see this data set. This data set has latitude, longitude. Yeah, not that good. Median household doesn't matter that much. House price prediction. Let's see this data set. This data set is also not useful. इस डाटा सेट को देख लेते हैं। यहाँ पे भी हम लोग को लिविंग रूम और 18 कॉलम्स मिल जाते हैं, और दिस इज द सेम डाटा सेट। सो दिस इज नॉट द डाटा सेट वी आर लुकिंग फॉर। ऐसे वी कैन लुक फॉर सम डाटा सेट विच इज मच मोर बेटर टू यूज, राइट? So let's see which data will be good for us. This is 8 years, 4, 5. Let's see this data set. This data set is the same. Most of the data sets are same. People are re-uploading it. So yeah. There is one more data set which is this one. This is targeted price test.csv, under construction and all those. Yeah. This data set is also not that useful. Let's see this data set. And this data set has residency, plot config, slope of properties, train CSV, MS zoning, MS class. There are a total of yeah. So this is the basic data set we are using. If we don't find any perfect suit of the data, right, we will be using this one only. So let's see this one. This one is overall fine. These data sets are good, but there should be sales price also. Yeah, that matters, right? Because without sales price, it will be hard. Okay, let's see. Because this data set is good. Yeah, here you can see sales price is there. So sorry, we will be using this data set. I will be importing this. I already have this data set, I guess. Yeah. So we will be importing this data, and we will be working on that. So here is our project. Let's go to file. There is documents, and then export, and then there is a project which is 100 ml. ml2 train एंड या यहाँ पे आप देख सकते हो। तो देखो ये एक बेसिक आउटलुक है कि कैसे होना चाहिए, हाउ शुड यू मेक इट, राइट। तो वी इम्पोर्टेड इट एंड इसको हटा देते हैं। तो पहले इसके ही बारे में बात कर लेते हैं, लेट्स टॉक अबाउट दिस। ओके, सो दिस इज अवर मॉडल। ओके, अगर यहीं पे मैं एक IPYNB फाइल बना दूं जिसको बोल देता हूँ हाउस प्राइस predict.ipynb, राइट। यही बना दिया, ठीक है। अब मैं यहाँ रिक्वायरमेंट भी डालूंगा, यहीं आ जाएगी, मेरे मॉडल्स भी यहीं लोड हो जाएंगे, मेरे सारा चीज़ें यहीं पे आ जाएंगी, और वो फिर बहुत कॉम्प्लिकेटेड हो जाएगा। व्हाट इफ मैं एक और मॉडल बनाऊँ, फिर तो और प्रॉब्लमेटिक होगा, राइट। चीज़ें थिंग्स विल गेट मेसी, सो वी फॉलो अ बेसिक स्ट्रक्चर। So we will be talking about that, the basic structure. Okay, basic structure which I follow, where like it's fine if you want to follow it or not, but yeah, there is a basic structure which I follow. So the first thing is there should be a folder. Okay, there should be a dataset folder. Okay, in that dataset folder we will be having files. So the files will be like this. So .csv file. See, it's not compulsory that you use .csv in your project. Sometimes you have to use different files. Okay, like you can use, sometimes you have to also work on JSON files, so you can use those also. But the thing is, those .csv, those files, okay, Excel files also, whatever, those files should be in a proper folder, which is dataset folder, right? So this is how it is. This is our main folder for this case we will be talking about. So I will make a big one. This is our house price prediction, right? House price, price prediction, there is no double T, so yeah, ये हमारा आ जाता है। इसको थोड़ा बड़ा कर देते हैं हाउस प्राइस प्रेडिक्शन को, और इसको यहाँ से लिंक कर देते हैं डाटा सेट से। ये हमारा लिंक हुआ। अगला जो है हमारा वो होना चाहिए कि SRC, दिस इज फॉर द बैकएंड। ओके, SRC हमारा जो होता है बैकएंड है, जिसमें जितनी भी फाइल होती है, जैसे हमारी इनपुट फाइल हो गई, मेन फाइल हो गई, तो उसको हम इसमें डालेंगे। तो मैं डाल देता हूँ, यहाँ तो दिख नहीं रहा, तो हम लोग स्क्वायर को ही लाते हैं। स्क्वायर इज यूज फॉर फाइल्स, लाइक नॉट जनरली, बट आई एम यूजिंग इट फॉर फाइल्स। ओके, तो स्क्वायर मैं फाइल्स के लिए यूज़ कर रहा हूँ। तो इसमें मैं बता देता हूँ, जैसे app.py है जो कि एंट्री पॉइंट है, ठीक है। एंट्री पॉइंट यू कैन ऑल्सो मेक डिफरेंट एंट्री पॉइंट, तो जो है उसको मैं डाल देता हूँ SRC में, और SRC को डाल देता हूँ यहाँ पे, फाइन। और भी होंगी फाइल्स, ठीक है। ये app.py इज द स्टार्टिंग पॉइंट जो मैंने लिखा। हो सकता है हम लोग और भी यूज़ करें, जैसे output.py यूज़ करें, प्री प्रोसेसिंग, प्रोसेसिंग, लोडिंग, ऐसे करके हम अपने यूज़ केस के हिसाब से चीज़ें चेंज कर सकते हैं। देन हम बात करते हैं, देन वी विल टॉक अबाउट अदर, दैट इज रिसोर्सेज, RESOURCES. So why is this resources needed? What if you want to have an image? If you want to save something which will be used, okay, in the when you are deploying it on GitHub or something. So उस टाइम पे how will you load it? If you load it in the same folder, I said it looks messy. That's why we have this. So here what we do is we have images. This is our images. Okay, so here we do have images, and we will be linking it from this one, fine. Yeah, this one we will be linking it, and then there will be other files. So there is one more, the QUI requirement file, requirement.txt. If you know, when you deploy requirement.txt with the version of which module or libraries you are using is really useful. So if you already tell them which one is useful, which one to import, which one to not, sorry, that is a plus point when you make something. Okay, so here we are using requirement.txt, fine. Then there are other things which will be there. Here will be our house.ipynb. So this is our main notebook. Why I made it in the folder section only? There is a reason for it, because notebook on itself is a complete file. Okay, it is the main file for reproducibility, or if anybody wants to understand that what you did, what you didn't, okay, the process which you followed. So notebooks are really useful. So that's why what we do is we maintain a same folder for it. No, sorry, we have it in the same place where all the folders are. So here will our IPYNB or notebook will be there. Then one more important thing, when you deploy it in GitHub, let me make a space for it. थोड़ा थोड़ा साइड हो जाने का इधर, अच्छा ओ या, और अब थोड़ा ऊपर हो जाओ, and then here, and do we have a space for it? Yes, we do have a space for it. Then what we will do, so here the thing is readme.md, because whenever somebody is going to open your MD GitHub, they won't be able to see anything, so you have to mention everything in a readme. Okay, and having a good readme file does help. So this is how I make it. Okay, and this is the thing, if you want to follow, you can follow. It is really good. Okay, this is how I do structure my folders and all. So this is something which you need to worry about if you want to make really good projects and make them easily readable for the other person also. Okay, for the other person to understand that how your project was, what you did. Fine. Here let's start with our data set. Okay, so this is our data set folder. Our file will be here. IPYNB file, which is notebook, will be only here. Resources file. Then our new file, which will be models. Okay, not models. It should be not file. Okay, did I mention it that models should be there? MODEL. Yeah, I did. I guess I did, right? That there should be one more folder for models, not this one. Here, when we are talking about this, did we have a models folder? Oh, we missed one. So there should be one more important thing, which is, let's do it like this. Okay, yeah. So there should be one more important folder, which is a models folder. MODELS, models folder, in which we will be storing all of our models. So if somebody wants to directly access it without thinking about which of the backend or how your backend works, they just want to see your models file and import them and check it. Okay, so they can use it directly. So here what we will be having is our pickle files. .pickle files will be here, right? .pkl files will be here. I generally use pickle. There are other extensions also and other ways also you can store your models. So this is how it is. Let's connect it. Fine, it looks good. Let's cross it. Okay, let's minimize it and let's come here. So here is our models. I will make one more folder, which will be for here we are having resources, dataset, models, and a new file which is readme.md, which will be containing all the data. These days everybody use AI to generate it, right? But mind it, give AI proper context, proper details what your project is about, so that it can use all the proper, like all the things which are there and generate you a really good file. So let's directly jump into the model training part and model pre-processing, loading, and how the notebook should look like. Okay, so let's start from here. I will once again write house price predict. See, here you can see select kernel. Let me just this is how it is. This is markdown, you already know. Okay, so before starting, let me clear few things. Okay, coming to the webcam. So as I said before starting this project building, you should already know some things, and those things are like a brief or a small description about all models, that how all models work and why they are used, when they are used. We will be discussing it in our live. But the thing is, when we are talking, I don't want you to get overwhelmed. Take your time, okay, understand why we are using it, why we are not using it. You should know how Jupyter Notebook works, how we select kernels, what is a virtual environment, and all those things. If you don't know, take your time, learn it, then go through the project, okay, then you will be easily able to understand everything. So welcome back to the screen, and here we will select my class environment, and we have already pip installed all the things, okay, otherwise I would have added it. So let's write one more markdown, which is our hashtag 1 point, which is importing libraries. Okay, so we are going to import libraries and all the things. So here we are having our code, which is import. We will be using pandas as PD. Sorry, as PD. We will be using import matplotlib dot pyplot as plt, and we will be importing Seaborn. Okay, Seaborn as SNS. So these are three things which we are going to use for now. Later on we can include other things also, but for now we are going to use this thing. So let's write the code. Before that we will write the markdown. So this markdown is our second thing which we are going to do, is importing our dataset. Obviously we will import dataset, right? So dataset, or we can write that loading is a better word for it. Loading is a better word for it. Loading dataset. So here we are loading dataset, and okay, so we will be using a data frame. I hope you know what data frame is in pandas. Hey. So we will be starting with pd dot read csv. See, panda can read all the things which I was talking about. It can read your csv, excel, feature, html, json, orc, pickle file also. It can read everything, and generally we use our pickle file only for it. Okay, we will be using it further. So first let's talk about this. So first we will be importing our read csv, right? Read csv only, read csv, and when we are using it, it's in dataset folder, dataset slash, what's name of it? Its name is HOAC house, PRAC price, PREDICTI.csv. Yeah, so as you can see, we have loaded it. Let's check. Oh, we have to import all the things. So we will do clear output, run all the cells, and here it loaded. Now let's see how our data frame looks like. So here our data frame is, here we are having different things. First is our ID. We can see ms subzoning, zoning, lot area, lot config, overall condition, build year, okay, added, and exterior, and sales price. See, even if we are not using all these things, we will be focusing on sales price relation with our zoning, area, lot area, okay, overall conditions, year build, and ms subclass. Okay, so we will be thinking about it, and we will be dealing with it. So like I just saw the data, I don't know much about it. So how can I think that what the data is, and how can I do some visualization about it? Okay, so we will be writing it, which will be 2 point, maybe let's go for 3 only, 3 point, or we can write it like hashtag 2.1, right? 2.1, and which will be visuals. Okay, so we will be using matplotlib to visualize how our data is. Before that, you can see this id section, right, which is repeating because by default our pandas give all the rows id and there is already id, so we will be removing it in the data cleaning part. Okay, so first let's talk about visuals and we will be making it. So let's write the code. So first we define as plt dot sorry. So first we will define the figure. Okay, that we need a figure of size 9,5, I guess. Yeah, 9,5 will be a good size which we'll be using, and it comes under figure size. So figure size, size. So in figure size, that is equals to this, we will be making our pipe. See here. Now we will be sorry. We will be starting with basic plot. So plt dot plot. Let's think about it. Like how should we make it? I'm not having much idea how it looks, what the relation looks like, right? So what we will be doing is we will be just thinking about it, visualizing, right, and trying to figure out how can we improve all the things. So here we can directly plot, right? We are having df1 and df2 and we are using pyplot. So I was thinking about it, just a second, that we are using df, right, and we are using plot. So if you know, plot is used for line plot. Okay, and it doesn't require any different, like much different thing. But the main problem is the data should be continuous. Okay, so the data is like, the data should be continuous. The relation should be like linear, not linear, yeah, a linear relation, but a continuous relation, to be honest. Like a continuous relation is plotted really good with a plot, but here I cannot see any continuous relation. As you can see, this lot areas is also not sorted, this sales price is also not sorted, and all those things. But still, let's check and let's just see that how it looks like when we are using it for a non-continuous data. I'm thinking there will be something funny because the relation is not linear, right? So still, let's do and see. So the second thing will be plt dot title. I guess with Seaborn it will be better. Okay, like when we are using Seaborn, it will be really good. So let's give title XYZ for now. We will be, but giving a meaningful name always helps. So it will be lot area versus area, lot area versus price, price. Okay, so this is our title. We have to give plt dot x label, y label also. So our x label will be lot area only. Our x label will be lot area and our y area will be same, just doing it with y command c, p command v. Here it will be y label and here it will be price, price, and then we will do plt dot. So I hope there is no typing mistake, so we don't get any error. But yeah, so there is no attribute x label, plt dot x label. I guess it is there. See, it plotted, but matplotlib.plt.spl. plt.x label, there is nothing like x label or y label. Okay, fine, then we will be in plot, there is nothing like that. Yeah, so see, so we will be using lot area versus price, and see, it looks really messy. As you can see, we are not going anywhere with this data, right? We are not having any good analysis about data. Like, this is just messy. I was just showing you that when you start, okay, It's not always that you will get a good data and you will get good things. Okay, sometimes you get messy things. Don't worry about it. Let it be here so that we can see that how we improved. Okay, so first we will now use SNS, because SNS is really good for big data. So we will again use this, copy this, command C, command V, copy it, copy this part. Let's do command Z also, so that we don't have to write all the things again and again, which is command V, yeah, here, and we will be running it from here. PLT, right? We use PLT, yeah, we use PLT. So now we will be changing this thing, okay, and as we already used this, so this is the main line. Okay, this is the main line which use line plot, okay, which used line plot. Okay, so but line plot was not useful, so we will be using SNS, and we have already imported SNS here. So let's see how it goes. So let me think now, which data can I use? I guess let's use a scatter plot with lot area in it. Okay, and in SNS we have to define it differently. SNS is used for, like, I defined it as C1. Okay, so here will be scatter plot. Here we have to define X, Y, and the data. So I will be using X is equals to, again, the same thing, which is sales, I guess, SALE, sales, SALE, sales, PRIC, price, and Y was the lot area. So Y is equals to LOT, lot area, like this, and it should always be sent in a form of string. And now the thing is that how our data looks. So our data looks is equals to dframe. Dframe is this, our data frame is this data frame we defined as df, right? So this is how it looks like. We send all this data like this, but we don't send below things. Okay, so I'm a bit confused about it. Let's check and see that whether it works or not. There is again a problem. Okay, and I guess there is some problem with my spelling. Yeah, the problem was with my spelling. So here it was label, not label. Yeah, that was the problem. Okay, now if we run it, yeah, see, the problem is with my spelling. So here we can see that there are less outliers. Okay, this section is for the outliers, but there are less outliers, and majority of the things are like accumulated here only. So what we can see is we will get a linear, we can get a linear relation out of it. But there is one thing which is we have to consider is, here we are not only having numerical data, we are also having other data which are categorical data. Okay, so thinking about which model to use will be one of the thing here. What we can do is now we can plot. Okay, for the same thing we can plot a scatter plot is not that useful, and we was not able to visualize much more things, right? So what we'll be using is let's use a box plot. I guess box plot will be really good. So here is our box and not box, and it will be just box plot. And in box plot the details which you are filling are different. Okay, so it checks overall things and then it gives the data. So what we can do is just think about it. In box plot what we can give, so lot area won't be good. These are all categorical data. I guess overall condition suits really well. So let's go for overall condition, and let's remove this and df, and then this. Inside this we have to give lot area, comma. Here one more thing is there, that I think we should also go for mean. Okay, so that we can see that whether the mean. So mean. First let me do it, then I will show you why I did it. Okay, so mean is here. which we are using, and I guess it should work. Okay, so let me discuss about it. Okay, first the thing is overall condition. We are seeing that these overall conditions are tagged. Okay, if the overall condition is 9, that means the condition is really good. If overall condition is 1, that means the condition is really bad. But we can see that majority of our data lies between 7 to 4. Okay, and then above is obviously good. Okay, but the below is not that good. Okay, so अगर आपकी हाउस की कंडीशन 1 2 3 है, ठीक है, मतलब बैड कंडीशन, तो जनरली वो उसकी रीसेल वैल्यू कम हो जाएगी. वेरी सिंपल टू अंडरस्टैंड, राइट. और हम लोग का जो डाटा मिला है उसमें हमने एक चीज़ नोटिस की, ये सबकी रीसेल वैल्यू जो है, सॉरी, सबकी हाउस की जो कंडीशन है वो लगभग 6 से ज़्यादा ही है. मतलब अच्छा ही है जो घर वो बेचना चाह रहे हैं, दैट इज़ अ गुड हाउस, तो वो जनरली बिक ही जाएगा. तो हमको इसका जो रिलेशन मिल रहा है विद सेलिंग इज ऑल्सो गुड. ओके, देयर इज वन मोर थिंग विच वी कैन डू is we tried scatter plot which was fine, but let's talk about sales price. Okay, तो यहाँ पे इसको रखते हैं, SNS को लाते हैं, वापस एक प्लॉट बनाते हैं और एक बार सेल्स प्राइस में देख लेता हूँ कि सेल्स प्राइस का कैसा ही है. अगर देयर विल बी एम्प्टी थिंग्स so we have to remove the empty things, but for now I guess SNS प्रोसेस कर लेता है इस चीज़ों को. तो सेल्स प्राइस हम देखेंगे और इसमें सोमीन हटा देंगे और इट वॉन्ट बी अ बॉक्स प्लॉट. आई गेस इट विल बी अ बॉक्स प्लॉट एंड देन वी विल बी यूजिंग y इज इक्वल टू दिस एंड फिर PLT शो कर देंगे. तो PLT डॉट शो, क्या हमें टाइटल देना चाहिए कुछ, आई गेस दे देना चाहिए, बिकॉज टाइटल देने से क्लियर हो जाएगी चीज़. मैं अभी जस्ट ये बता रहा हूँ कि हाउ डू वी डू इट. ओके, मेरे से हो सकता है कुछ चीज़ें छूट जाएं जो कि आपको जब आप बनाओ तो आप याद रखना, सो दैट यू कैन इम्प्रूव इट लेटर. वी विल बी रिव्यूइंग इट अगेन इन द होल प्रोसेस एंड वी विल बी फाइन ट्यूनिंग इट. So all the people who are in the live, make sure that you comment also. Okay, sorry, not comment, you just chat something so that it will be easy for you to understand. Also, if you get any problem, you can just say hello, hi, anything, so that this can be much more interactive. So यहाँ पे हम क्या करने वाले हैं, now we will be doing PLT dot title, right? So here our title will be what? We will be making it sales price, which is here. Sales price versus count. Okay, so this is our title. Hi, so here we are and let's run it. So we can see that the box is not coming that, like, doing a data analysis here is getting much more trickier for us, right? We are not able to extract something really meaningful out of it. So fine, we will be leaving this part. Okay, we will not be thinking about it much more. It's fine. We are seeing some data which is useful, but not that valuable data, but that valuable insights are coming out of it. Okay, so fine, we will be leaving this as it is now for the visual part, and we will be moving on to the data cleaning part. So here we are, and yeah, let's talk about this. That is 3 point, which is exploratory, exploratory, exploratory data analysis, SIS here. So we will be doing our EDA, which we already did, but which we were not able to extract anything meaningful out of it. So we will be leaving this. Okay, and then we will be moving on to the other thing, which is our data pre-processing and cleaning part. So here we are, 4 point, which is data cleaning, CLEANING, data cleaning. Okay, and here we will be cleaning our data. So this code is here, and let's start the data cleaning. So when we talk about data cleaning, what are the things which come to our mind, right? That there will be some missing values, there will be some irrelevant values, okay, which we will be dealing with. So first, let's see that how our data frames look like. So this is our data frame, and we can see ID is a irrelevant value which we will be dropping anyways, and then sales price is fine. Sales price we need, but there is any value you can see which is not defined value, so we'll be dropping it out also. So first we will be doing by dropping df dot drop, and we will be using id, okay, and then we will be using, we will be dropping, and then it's only in access, so we will be using access equals to 1. Fine. So what we are thinking is dropping this id section, okay. After dropping it, we will be having our data much more clean, because if it is there, it is irrelevant, right? 1 2 3 4, we don't need to train our data on this, sorry, our model on this. So we will be dropping it, and we dropped it. Now we can see df, and here our data is much more cleaner, okay. Now we will be doing one more thing, that after this we will be checking how many values are null, okay. So we will be doing is null count, and that will be our df dot is null, okay, is null dot sum. Is null is also a function, so we will be doing that. We will be using our parenthesis for it, and then we will be seeing that how many values are really is null. So let's copy command V here, and we can see that in sales price there is only one null value. In this in Amazoning there are 4 null values, but the main thing is that it's like out of 2000, right? We will see, just a second here, out of 3000 rows, our 1500 1460 rows are already null. So how can we train our supervised model on it, because there is no labels available, and if there are no labels available, training them on blank value is useless. So we will be removing it, okay. So this is the second thing which we got. So let's do it, and which will be df is equals to df dot drop na, okay, and then the subset will be our sales price, SALE. We can already copy paste it, command C, our sales price, see. So this is our sales price, and we will be dropping it. Now we will be seeing that how our df looks like. Here we are having less data, but the thing is we are having the most relevant data for this data, okay. So let me remove this here, remove this from here, command X. We will be going here, and this is command B, and then the data will be cleaner. So let's make it much more cleaner, deleting this part, bam, and we will be clearing all the cell outputs, running again, and here we are having clear data. See, you can see that all the data is having no null values now, okay. Now we are talking about our train test things, okay. We will be also doing one hot encoding or feature encoding, which I was talking about. So we will be doing it. So first let's do one thing, which is let's just separate it, okay. So we will be having our data, not generate, we will be having our data, which I can, x is equals to df, right? In df I have to make our x train, which will not which will have all the features, and then there will be y, which will be having y, which will be having our sales price, so that we can form a relation out of it, okay. If I can show you, here is my Google, yeah. So let's talk about it, okay. So here we are dealing with this kind of line. One more line, which is here. Okay, so here backspace, let's do this. So here, as we can see that this is our line. What when we are talking about this much features, like it is just a 2D. So let's suppose this one is our height line, okay, and this one is our size line. So we can find a relation out of it, that whenever the size is increasing, the size is increasing, on average how much inches of the height are increasing, right? We can find that by this curve using the slope of it. And if somebody says this, when we find the perfect line for it, okay, the best fit line which we say we find for it, if somebody says that this is, let's suppose, can I write something here? I guess there is nothing to write, right? Okay, fine. So what I was saying is, when we are talking about this, let me make it bigger so that we are easily able to understand it. See, when we find this best fit line, okay, we can find the perfect relation for it. Perfect relation for the 2D diagram, 2D case which we are having, okay. If on an average this is the height, okay, this is the height. If the height of the person is this is the size, this is the height. So if the height of the person is, let's suppose, 7 feet, okay, that means his shoe size will be, majority of the times his shoe size will be more than 7, 8, 10, 11, right? So this is the relationship we are able to find using this, and the same logic is used, okay, for our all the cases. This is in 2D, then it will be in 3D and other cases. So this is our person. Hey, see, he's saying hi to you guys. Hi, hello. Okay, so leave it for now and let's come here. So this is our models, and yeah, we will be having our data frame which will be having our all features, X which will be having our all the features, and Y which will be only having the sales price, so that we can form a linear relation out of it. Generally in this case, what I can see is, as there are values which are non-numerical. See, numerical values are just 60, 20, okay, 70, 60. These are numerical values, but there are values which are non-numerical, such as one farm, inside, FR, corner, right? RL. These are non-numerical values. So when we are talking about non-numerical value, generally our model, which are linear model like linear regression model, lasso, then ridge, which we will be using, those models generally fail, because they can only process better, only process things which are good with numerical things, right? So they can easily process it, easily find the best fit line for it in their dimension. But the thing is, when we are talking about n categorical data, generally they do fail, okay. So let's just do one thing, that X will be dropping sales price, right? So sales price, and so this will be axis equals to 1. From axis 1 will be dropping the sales price data frame, and we will be closing this data frame. Why I'm not able to? Yeah, so we'll be closing it, and we'll be using this drop. So df drop na. So we are dropping our one column from it, which is sales price, and we are adding one more thing, which is I see, generally we use a small y, but I do use capital Y because it's better for me to understand. And we will be using our df, which is our other data frame, and we will be using it for the sales price. Now I will show you something interesting, just wait, okay. So I will be showing you a really interesting thing. Now this is our data, and from here we can find a linear regression. Sorry, linear connection between both of them. So we'll be doing it, and then we will be using train test split on it. Before that, we will be using a feature encoding thing, so that we can convert all these things. Encoding, one hot encoding. What we can do is we will have a cat column. Okay, cat column that will be having our x dot select, select. So these are all the things, I guess, if you know, or you can use documentation for it to understand. Okay, that you can see documentations and easily get all these things, that how we do encoding, how we make all the data, how we visualize things, we can do it. So we will be including, that is equals to object. I guess, just a second, let me check. Didn't I mute or something? Okay, fine, it is already 1 hour, but yeah, we didn't mute, and I guess the video is clear. So here we are, again starting with it. So we will be including our objects, because we need to include it. There is a exclude also. Exclude is equals to object, so that will be used for excluding all the objects. Then we will be having columns, columns, columns. Okay, so we will be having columns here, and then we will be using x is equals to, this is how it is done. Okay, this is how get dummies, and x comma, we will be having columns is equals to, it was cat, yeah, we defined it, cat columns, right? So this will be cat columns, and then we will be drop first is equals to true. So this is how our one hot encoding is done. Here are a few features which you can change, that you can also do one hot encoding false, or you can not even include it, but those are the things which will understand with time. So take your time and do understand it. So first we're talking about the one hot encoding, we are doing it, and then we will be using our bull, we will be changing our bull columns also. This is bull means boolean. Okay, so which are things like already here, if we are having this bst, and if these all will be converted to bull, right? Bull means boolean or something, if they are only having two values, so we are doing it for that. So it will be x dot select, select d type, right? Select d type. Then in this we will be including include, include spelling is wrong. Here we are having include 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 dot object, and that columns. Okay, so we are having include dot columns, and we are having our stuff here. Now here it won't be object, it will be bull. Okay, bull means boolean value, so we are having boolean value. Then we will be having x, capital X, and then we will be having boolean column, bull calls. Okay, that will be converted to x dot bull column dot as type. Okay, this is type, and we will be converting it to int. So when it was boolean, true or false, now it is getting converted into our zeros and ones. So zeros and ones are much easier for our system to understand. So let's clear all output, run all, and let's see, there is some problem here, which is drop any takes first argument and second argument. First one is keyword given by itself. So drop any takes first positional argument. So here we did some mistake, I guess. Oh, we already dropped it, right? We already dropped it here in the data frame. So if we have already dropped it, we don't need to drop it again. So that's why if we run it, access not found, clear all output, and let's run it, and yeah, so we have already dropped it. Drop any for x we have did, which is drop id, so we have to drop id, and then drop any, which is Here we are using drop any. Okay, so let me see. We are not dropping value, we are just using x and y. So here we are using sales price. I guess the spelling is also fine. Access is equal to 1 is also fine. Drop, I guess here it should be just drop, not any, because they are not dropping any null values, right? So let's run it. Okay, there is still value, clear all, run all. And here still there is problem, df dot drop, and then sales price. Okay, so we are not dropping a data frame, we are just dropping sales price. So let's run it again, and yeah, here we are having problem in this clear all, run all. We are having attribute one hot encoding select type. There must be problems. Let's solve it. Can you see any problem? If you do, just tell me. It's not select type, it was d type or what? No, it was select type only, right? It was select type only. I guess select d type. It was select d type, means like select data type out of it. So it was like when we are making x, which is our dropped anyone, right? See here, if I am running it again, it will give me no error, but if we are running it again, it will give me an error. It is not an error. The thing is, we have already dropped the id, so it will show me the error. So already, as always, we have to clear output and run it again. Fine. So this is how it works. So you can see it is running really proper, and we have done one hot encoding. So now let's see that how our data looks like. So here we are having x. We will be running it again, and here. So you can see that what it does is all the things are converted into zeros and ones. So all the things like MN zoning, it made it a column, and it gave it like whether it was true or false or not. If it is present in that category, so in that column, it is given 1, otherwise it has given it 0. Okay, so this is how our one hot encoding is done, and now we are having all numerical things. You can clearly see it. So here we are having x. So now let's do train test split and move on, right? So here we are having our fifth one, which is hashtag 5 comma 1 hot encoding, right? No, we already done it. It's train test split. Okay, so as you can see, it's train test split. Okay, and we will be doing it. So here are the codes. So in train test split, for train test split, we already have a module in sklearn. So we have to import sklearn before that. So let me import sklearn dot features. Okay, so here just a second, let me show you. Here we are going to sklearn train test. Okay, sklearn train test split. We will just go here, we will see the documentation. Always go for the documentation rather than ChatGPT or something, because when you go to documentation, right, you understand things instead of just copy pasting it. Here also we will be copy pasting it, but when you are forced to update things, it really does help. Okay, so here it says numpy as np, so we will be importing it here. We have to import numpy also, right? So import numpy numpy as np, right? Here we are importing that and copying it. So let's not make it, or let's not see it. This is not we want to do. So this is how we are having our train test split. Numpy was already there, remove it, train test split. So what we do is x train is here. We are having our x train, y train, yeah, this line. Copy it, let's cut it because we don't have any use for it, right? Let's cut it, and before that, let me go through some chats if it is there. So yeah, I fixed the chat thing, and now we can just copy paste it. Here we are having our copy paste x train y train out of our data set, which is x and y. So this is our x and y data set. See, here the test size defines that how much data you want it to be. Just a second. So it defines that how much your data should be splitted. Okay, if we are giving the data size, okay, so here we are, we were talking about this, that this test size defines how much your data will be splitted. So there is like, when we are talking about complete data is 100, right? So it's 100%. If we split it in 80 to 80 slash 20 ratio, we can just write it as 20. So it will split the test size as 20. Okay, and the other size will be, the train size will be 80. If we want it in 70 to 30 ratio, okay, 70 to 30 ratio, we can change it. I will show you the differences also, then we make it complete, right? We will do it. I will show you that how this training data and testing data changes matters. So for now, let's remove it. So this is our x train y train, and we are training our data on it. Okay, so we will be using, why splitting is important. There is one more thing. Splitting is important because we don't want our model to already know the answers, right? It's just like you're creating a question paper, okay, giving a person all the information and data which are required to solve this. How much he has learned will be evaluated by a question paper which he has already not seen, right? अगर उसको आप क्वेश्चन पेपर ही पहले दे दोगे तो फिर वो तो ऑब्वियसली उतने को ही पढ़ के जाएगा, पेपर दे देगा, 100 में 100 मार्क्स आ जाएगा और आपको लगेगा उसको सब आता है. बट व्हेन रियल वर्ल्ड और प्रोडक्शन में ये चीज़ें जाएंगी, then he will always fail, right? That's why we have to do it. So I will show you the differences. There are not much differences, but yeah, I will show you later on. So अब हम अपना ट्रेन टेस्ट स्प्लिट भी हो गया. Now we can do is, now we can start our model training part. Model TRN training and evaluation part. Okay, evaluation. So we are having our model training and evaluation part. Here, which model to use? As I already said, we are already having a labeled data, so we will be using an supervised learning model. Okay, in supervised learning model we are having different models, but what I can see is now we have changed all the data in a numerical form. So I can just think about it that a linear model, a linear regression model will be good. But as I know that there was categorical data also, I know it won't perform good. Boosting model or a random forest model would be performing much more better. But let's see, and then we will be also trying its variants after the regularization, that how they work. Okay, so here we are having our codes. Let's start. Okay, so this will be our linear regression. Okay, so what can I do is I can also make one more markdown, which is 6.1, which is in hashtag for a smaller, and which will be linear regression, regression, linear regression. Fine, we will be making the other models also, and we will be naming them. So for linear regression, what we have to do is we do import, right? So we will be importing model, and we will be naming the model, and then we will be trying to fit it. Okay, and then we will try to predict. So I guess we are already familiar with the import things, and we will be also importing a R2 square. Okay, so we will be also importing R2 square. This R2 square will be helping us to evaluate. So there are different evaluation metrics. There is error. Okay, so there is root mean squared error. Okay, which is called RMS. But what we are using is R2 for our scenario, for our case for now, for the time being. So we will be naming it LR model. LR is for linear regression model. This is the name, fine. And then we will be treating it on a linear regression, and this is how you make a model. Okay, it's really simple when you use sklearn. Okay, training them is really simple, but thinking about it, that why to use this model, I also don't know that this model will work or not. Okay, I'm just trying to fit it. If it doesn't work, we will be moving on to some other model. And we should also know that why this model won't work. That is also one of the important things, because the thing is, there are categorical data, there are numerical values which are not well linearly maintained, right? So that's why. Now what we are doing is we are using our LR model to fit. LR model to fit, and we will be training our. So here it already said that x value, y value should be there. The thing which we want to train, the features, the first will be our feature and the second will be our testing thing. Okay, so it will be x train, which we already made, and this should be capital. I always keep it capital for my cases. Okay, so it will be x train and y train. So I will copy it, paste it, comma, paste it. It is for y train, fine. And then we will be using yPredict. So I will be explaining you. If you're not getting it, I can explain it again. You can just write in the comment chat section that whether you are able to understand or not. I can explain it further if you want to, that why we are doing it, why we are not doing it. So this is our LR model which will be used for prediction now. Okay, so this is where having again making one more variable where we will be storing our LR model data frame. Okay, sorry, LR model predict, which it will predict. So we will see that whether it has predicted right or not. Okay, so how will we check it? That the prediction is checked on our test data, right? So our test data, extend data, test data. Let me just complete the course, then I can explain you better at the time. Okay, so LR model, and then it will be predicting. So yeah, it is predicting. Okay, so let's talk about it. First, what we did, we imported linear regression. Then we did sklearn matrix, that is R2 score for our evaluation. We will be using later. LR model, a linear regression model, we made a variable and made a model for it using a linear regression function. Fine. Then this LR model which we made is used to fit, is used to train. This is a dot fit is used for training. Okay, so we are training our x train and y train. Okay, not y train, we are training our x train on the data y train. Okay, on, like, we are trying to form a relation between x train and y train. So whatever the best fit line it came up with, now we are trying to predict it. So our LR model dot is splitted, and then it will be y test, and here we are having y predict. So as you can see, now it will check both of them. How? Let's talk about it. अगर इसने बोला कि आपका ये केसेस हैं, ये आपने वैल्यूज दी मुझे, इसकी वैल्यू आती है 10, फाइन, इसकी वैल्यू डिसाइड होती है कि इसकी एमआरपी वैल्यू है 10, बट असली में क्या उसकी एमआरपी वैल्यू थी, मॉडल ने प्रेडिक्ट किया उसकी एमआरपी वैल्यू 10 थी, बट असली में क्या थी, 50. दैट मीन्स कितना डिफरेंस आया, कितना एरर क्रिएट हुआ, ये कैलकुलेटेड. ओके, सो हम लोग इसको कैलकुलेट करते हैं कि कितना एरर आया और उसको R2 स्कोर से चेक करते हैं. अगर उसने 10 बोला तो 10 ही चेक कर दिया तो वाओ, आवर मॉडल इज वर्किंग रियली फाइन. और यहाँ पे एक चीज़ आती है कि अपना जो R2 स्कोर होता है जनरली वो 50 से ज़्यादा ही आना चाहिए, वरना क्या है 50% तो मतलब तुक्का ही हो गया ना, तुक्का ही मार रहा है मॉडल पे. तो 50% से ज़्यादा अगर आ रहा है, 60% इज लाइक फाइन फॉर अर्ली स्टेजेस, जब डाटा सेट बहुत कम होता है, मतलब 1000 10,000 रोज से जब कम होता है, तो 60 इज अ फाइन वैल्यू, 65 इज ऑल्सो 70 इज फाइन वैल्यू. बट 75 से जब हमारा मॉडल ऊपर जाने लगता है, 75 80 90, ओके 100 तो वेरी रेयर, ओके 100 तो नहीं कर पाता, बट या दिस 75 to 90 रेंज इज रियली गुड. अगर आपका मॉडल इस रेंज में आ रहा है, दैट मीन्स योर मॉडल इज वर्किंग रियली गुड. दैट इज अ रियली गुड मॉडल एंड यू शुड यूज इट फॉर द प्रोडक्शन ऑल्सो. अगर 60 में है 65 में तो प्रोडक्शन के लिए उतना वैल्यूएबल नहीं है. वी जनरली ट्राई टू अवॉइड दोज मॉडल्स एंड देन वी विल चेक दैट हमारा R2 स्कोर क्या आया. ओके, सो यहाँ पे हम आते हैं और वापस से क्लियर ऑल आउटपुट करके रन ऑल करते हैं और हमको क्या कुछ एरर मिलता है. हाँ, तो हमको कुछ एरर मिला है. दैट इज मैसेज एरर एनी वैल्यू डू नॉट एक्सेप्ट मिसिंग वैल्यू एनकोडेड एनिमेटिव. तो हमने यहाँ पे कुछ ड्रॉप किया ना, ड्रॉप नो, यहाँ पे हमने एक गलती कर दी है कि हमने df डॉट हमने नल वैल्यूज जो की थी, नल वैल्यूज जो हटाई थी उनको वापस से हटा दिया था गलती से. तो हम उसको फिक्स कर लेंगे कि हमने जो हटाई थी वैल्यूज उसको ड्रॉप नल वैल्यूज, ड्रॉप नल वैल्यूज जो हटाई हमने वो हम लाते हैं सबसेट पे. सबसेट इज इक्वल टू सेल्स प्राइस. देखो, that's the thing that our model doesn't deal with the null values, so we have to do the classic data cleaning process, right? This is what we are building the model for, right? Oh, sorry, clear all output, run all, and you can see the model is now working fine. Here the model is predicting 61.95 something. So 61.95 is not a good not really good, right? It is not predicting much more than like 60% of the data. मतलब उसका अगर आप 100 बार एक टास्क दे रहे हो तो वो 60% ऑफ द टाइम्स लगभग ठीक गेस कर पा रहा है. इसको हम ऐसा भी कर सकते हैं कि R2 स्कोर जो है हमारा, उसको यहाँ पे मैं आपको एक चेंज दिखाता हूँ which we are talking about is here we are having a test size. So but test size is equals to 20 which I was talking about earlier also. Okay, that अगर हम टेस्ट साइज को चेंज करते तो क्या डिफरेंस आता है. अगर मैं इसको 33 ही रखता और वापस से अपना मॉडल रन करता तो तुम देख सकते हो कि मेरी वैल्यू थोड़ी सी गिरी है. मतलब मेरा मॉडल ज़्यादा डाटा के साथ अगर ट्रेन हो रहा है तो वो वैल्यू इम्प्रूव होती है. दैट्स व्हाई वी ऑलवेज से डाटा इज ऑयल फॉर द माइनिंग इंडस्ट्री वी आर हैविंग विच इज कॉल्ड द IT इंडस्ट्री फॉर नाउ. सो द थिंग इज दैट जितना ज़्यादा आप उसको अच्छा डाटा दोगे, क्लीन डाटा दोगे, सही डाटा दोगे, आपका मॉडल उतना अच्छा होते जाएगा. बट देयर इज ऑल्सो लिमिट, अ कैप. There was a research paper recently published that what are the limitations of AI even if the data is scaling. Companies are investing billions of dollars in this data center maintenance and training all those models on the data. But the thing is that there is a limit and a cap to it also. Okay, so we are talking about here that अगर हम अपना टेस्ट साइज बढ़ा देते हैं, मतलब हमें ट्रेनिंग डाटा सेट छोटा हो गया तो हमारी वैल्यू थोड़ी सी हिल गई. अगर हम इसको बहुत कम भी कर देते हैं तो भी प्रॉब्लमेटिक हो जाएगा. बताता हूँ क्यों. सो एज यू कैन सी दैट क्लियर ऑल आउटपुट रन ऑल. सी, अगर हमने टेस्ट साइज बहुत ज़्यादा भी कम कर दिया, डाटा को बहुत ज़्यादा ही ट्रेन कर दिया, बट द थिंग इज कि टेस्ट साइज का जो स्प्लिट बन रहा है, ठीक है, इस टेस्ट साइज के स्प्लिट में हमको एक प्रॉब्लम दिखती है जो कि है कि टेस्ट भी जो हो रहा है वो अच्छे लेवल पे होना चाहिए ना. क्योंकि अगर हम देखो, अगर हम एक ही या दो ही केसेस को मान के चल रहे हैं तो वो 2 केसेस हो सकता है कि एक्सेप्शनल केसेस हो, राइट. जिसमें हमारे टेस्ट का जो साइज है वो भी ठीक होना चाहिए, टेस्ट का साइज भी छोटा नहीं होना चाहिए. ठीक है, ट्रेनिंग साइज अगर बढ़ रहा है तो टेस्ट का साइज भी बढ़े तो बेटर है, राइट. दैट मीन्स वी आर टॉकिंग अबाउट होल डाटा ग्रोथ, नॉट ओनली कि ट्रेनिंग सेट में थोड़ा ज़्यादा डाल दिया, टेस्ट में थोड़ा कम कर दिया एंड वी आर हैविंग सम मॉडल्स, राइट. तो हमको वो नहीं करना है, हमको टेस्ट साइज को भी इक्वली मेंटेन करना है, फाइन. तो द बेस्ट वर्किंग इज इट्स ऑलवेज प्रेफर्ड टू हैव अ 80-20 split. That's why we are having 0.20, fine. And we will clear output, run it again, and we can see our model is like 62%, fine, which is the prediction it's having. Now just copy it again. Let's talk about codes. Here we are talking about another model which will be 6.2 and which will be RA. Let's talk about ridge regression first. I guess a ridge regression model will be really good. Okay, using L1 regularization for it will be good. So let's do for lasso and then we'll be using regression, fine. So this is our lasso regression, and we will be dealing with it. So what is lasso regression? There is bit changes. We are scaling our data, and lasso regression is bit optimized for it. Okay, so here how do we do it? Our lasso lesson, not only lasso. So we'll be copying it. Just a second. We'll be copying it. Command V, lasso regression, and here also we will be having our lasso. So yeah, we will be having our lasso, and we don't have a regression item. We guess we have alpha value. Alpha is equals to, generally we give it 0.001 or 0.01 is fine, but I guess 0.001 will be a better value. And here we have to import lasso, right? LASSO, not a regression, nothing, just lasso. So here it is. Okay, now we have trained our data also. Predict will be for lasso, LASSO, and our R2 score will be also for LASSO. Predict lasso, and then we will predict it. I will also make one more model, which would be a ridge model. Okay, so let's go for it. We will also be making, we don't have to import it again, it has been already imported. Command C for the copy, Command V, and one more markdown, which will be for 6.3, and that will be a RIDG, ridge model. Okay, so ridge, ridge, sorry, ridge. Okay, so we'll be just changing all the values here. Just a second, and we'll be testing all the things, that how are they working, how are they not. Yeah, here as you can see, we are having ridge. We are not using a scaled one, we are using the normal one, X-test and Y-train, ridge, and yeah. Now let's just talk about it. So we are having our three models here. All three models will be creating all the output and running it again. And let's see, there is one problem in the spelling. I guess lasso model is running with lasso, LASSO. I guess alpha is also fine. ALPHA, right? ALPHA, alpha. Yeah, so clear all output, run all again. So as you can see that this all models, even after the regularization, as the regularization helps, but as you can see that here, as the data set is really small, all the values are really close. Okay, they are not there is not much difference in all the values, right? 61.91 and similar. But what you will see a big change is when we are using some different models, just like random forest or our boosting models. So let's talk about random forest first. Okay, so this is our these are the last models we will be dealing with. This is 6.4, and which is our random FOREST, random forest, REGRESSION regression. I guess there is somebody in the chat. If somebody is in the chat, I'm looking for the chat. You can ask anything if you want to, be free about it, right? If you want any other guidance also, or any other problem also, you can ask me. Okay, so we are talking about codes. So here from sklearn, again FRM from sklearn, right? sklearn dot embed. We are using import random forest regressor. So we have imported our random forest regressor. Now we will be using it. So we will be using random forest model. That we will be doing is using a random forest regressor, and it will be having an estimator. So these are the parameters which we used to pass. The thing is, if you don't know about this, you have to learn really deep. You have to research more about it, right? What this course is assuming is that you already know all these things. Okay, this is not a course. This is just a model building lives which we are doing, so that on the go, if you are having a doubt, you can directly ask in chat, and we can improve the models on the way and move forward with it, right? It's not like a teaching live which I will be teaching or something. If you want those things, we can start from the scratch later, but let's build all the models we are having for now. Okay, fine. So again, we are talking about RF model. Here we are having RF model dot. Again, it's very similar. All the models we are using, we have to fit train, right? Fit train, and here we will be fitting it, training it. Command C, command V. Here you will see a really good difference. What is the difference between basic models and advanced models? Okay, so that other things you will be seeing here. R2 score for RF, that will be equals to R2 score. Yeah. Command C, command C, and here we are having Y test, but here we are not having Y predict. Here we will be having Y predict RF, and we will be closing it, but there is no Y predict, right? Y predict dot this. So what we'll be doing is we will be creating Y predict RF, and Y predict RF is here. So see what we are doing. Again, I will be explaining this part. So what we are doing is here we have imported random forest. As you can see, random forest is there. We have we have made a variable where the model will be stored. The estimators are 200. We can change the values accordingly. Okay, it's generally the length of the tree which we will be using, and in random forest we are making different trees. Okay, so for the same model we make different trees and see which model does work really best. Okay, so estimator is 200, which is basically what is preferred, and then we are fitting it. You know, fit is used for model training. Remember it. Whenever doing model.fit, it is used for model training. Training, how do we train? We train them on X-train thing, and for what we train? It's a supervised model, right? What we train? The level it is having is Y-train. Fine. Okay, let's move forward. Then we are using Y predict random forest. Why? This Y predict is used for predicting it. How? So that we can evaluate that whether our model was good or not. So this is Y predict we are having, and which will be the parameter which we are using is X test. So X test is here. We are training on this. Fine. Let's see. I am having high hopes for it. Let's go for it. 3, 2, 1, boom. Again, see, 61 only. This is not a good model. Okay, like this is not having a good value. I was having very high hope. Oh, sorry. I guess this should be RF, right? No. I am having high hopes, and you can see 81. Then you are saying that whatever the values or the parameters you give as test, or when you test the model, and you have 81 chances out of 100, 81 times the model is correct, that means the model is really good. Okay, so yeah, the random forest is working good. We can also try that is XGBoost, which is a boosting model. Then we will be summing up all the things. Okay, I am already having a thing where we compare all this, so I will be showing you through visuals that how it is. Okay, so before that we will be using from XGBoost. Okay, XGBoost. From XGBoost we will be importing XGB regressor, because we need regressor, not classifier. There is classifier also, there are other things also, right? In other videos which we will be having, we will be dealing with classification cases also, unsupervised cases also. So be there, and we will be building those models also. So here for XGBoost we are doing, which is xgb, and xgb is equals to xg regressor and then estimator. Okay, so we can name it as model, not only xgb. Oh, command z, command c, command b. So this is R2 score is for other and model. Okay, so let's make it as model and xgb. The parameters it takes are, one it takes is estimator as we are talking about, and there it also takes learning rate. Okay, which is used. So an estimator is here. We were using 200. We can use more. Let's see how does it changes with changing the estimator. So we did 100. Similar, not much change. Let's do 300. Similar, a bit improvement. Let's try to improve it much more. And we are having similar. So see, it is trying to find a good value, like a gradient, and here we are having the value which is 300, which is a really good value. Fine. For this we are having 200 for the estimator, and then we are having learning rate. So learning rate here, learning rate, that is equals to 0.05. it is a general case which we consider. Okay, then we will be fitting this model again, similar case, right? So we will be just copy pasting it, command C, command V, command C, command V, command V, xgb, this would be xgb dot, oh sorry, this would be so this would be our xgb, this should be our xgb, this should be our xgb. We are having xgb, yes, we are having xgb here, and our last model is here, which is having xgb. Fine. Now let's see that how our xgb regressor helps, or is it predicting really good. See, these models are advanced models and they generally work really good for such cases which are like house prediction. We are having mix of data. Okay, I will be explaining you all these things more like later. Okay, in this same video, just maybe in 10 minutes. So we will be running it again, and here we can see, yeah, see, it is giving us 82. So yeah, these advanced model like random forest and XGBoost are working really good. Okay, so I will be tagging it again, code, not code, it will be the markdown which we are having. It's 6.5, sorry 6.5, and it will be what, it will be xgb, sorry, not cgb, xgb and regresor regressor. Fine. Bam. Here, now I will show you a comparison, okay, which I already made for our R2 square comparison between all of our models which we are having. So we'll be having code here, and this is our comparison. Lasso, I guess lasso 1 is here, ridge is here, lr is here, lr is for lasso, no, okay, lasso, lasso, you should have told me, chat, that we are having it here. You can have informed me about it that we did a mistake there, but fine. Yeah, here we are having clear all output, run it again, and here. So as you can see, this visualization clearly tells us that linear, ridge and lasso are in a similar scale, but R2 square of random forest and XGBoost is really good when we are talking about performance. Fine. And then there is saving of pickle files, right? Saving and how do we save it and all. And then there is saving the version packages. In this video it's not there because I have to explain much more things. Okay, you can check it out on my GitHub. There all the things are there, but you won't find dataset there because I had removed the dataset and models there because there is a limit, right? If you want to push all those heavy things in 100 MB things, GitHub doesn't allow you. Okay, there is a limit to it. It is really slow. You can only put good codes and all things, other things there. So here it was. There will be one more thing, which is SRC, which will be using, okay, SRC, which will be using for the backend, and which we can use for the backend. Other than that, yeah. So model resources is there, SRC is there, all the things are already there. Now let's talk about one thing which is not available here, but which will be in my file already there, which is house price prediction, and in resources I have saved it. You can see it's well structured one, and here in resources we are already having this. So let's talk about it. Okay, this is the house prediction model. Which model which we are using? The 5 models which we already trained and saw. Here we are talking about a standard model. So here there is linear regression which follows which follows a thing which try to find the best fit line out of its equation. It makes equation. So here if it is using wx1 only plus b, that is a one dimensional one. If it is using w2x2, okay, this dimension depends upon how many features you are using. If you are using only one feature, one dimension, two features, two dimension, three features, three dimensional, right? So this is how it try to figure out the relations. Okay, it's really easy to visualize if you think about it. Okay, there was Gravi, I tried it, but it was not that efficient to visualize, but yeah, fine. So here the model is in linear relation, input and target variable, weighted sum, right? We are only talking about the advantages and limitations here. So you can see it's very sensitive to outlier, and whenever there is outlier, it generally performs really bad, because see, your line is like this, a simple line is like this, and there is an outlier, it just pushes this line to a wrong angle, and which affects its slope, and a wrong slope, wrong data. Fine. Similarly, in limit, the most important thing is, there is one more important thing, which is a neural network also is related to this linear regression, and linear regression is also known as mother of all the machine learning algorithms, which is very easy to implement, high interpretable, right? Computational efficiency, it's really efficient and all. Then we are talking about less of theme. There is one thing that it reduced overfitting of linear regression, and there is one more thing that in ridge also there is it's more stable, ordinary for least squares, handling multicollinearity effectively, something like, yeah, these are just upgraded version of it. They're also known as L2 regularization and L1 regularization just for the linear model. Okay, so apart from that, here are the advanced models. Build multiple decision trees, capture complex interactions, and reduce overfitting single trees and all. Less interpretable, but yeah, this works really good. Can compute intensive on large data set, and they're really good also. Okay, so then we are talking about XG, which is a boosting. Okay, you can see extreme gradient boosting, sequential tree building. Fine. So here we are talking about structured and tabular data, which we are already having. It also have built-in regularization, which avoids overfitting, and there is required carefully hyperparameter tuning and all the things. Okay, so we are having higher training time and complexity we are using it. So this was for the thing we have already implemented it. You can see the course here, right? You can go for it. So that's all for today. I will be closing the live for now, and yeah, if you have any doubt or anything, you can just comment also. You can if you want all these codes, they are already in the GitHub. Okay, you can check out the GitHub. You can also save the GitHub in your local system, try to run the code. Before that, make sure that you install all the things, pip install, you already know all the codes, pip install and all, and then go for it. if you want me to suggest some models also which should build further in the lives, you can also do that by directly contacting me in LinkedIn or GitHub. Also you can try, starting the repo and all, so you can see that these people have been connected with me. Yeah, that's all for today. Hope, bye bye.